All right, guys, we're back with section 7 of chapter 4. This is the last one for this chapter, and it's inverse linear functions. So previously, now this isn't in section 6 of this chapter, but this is several chapters ago, we represented relations as tables, graphs, and mappings. Now we're going to find what's called the inverse of a relation and find the inverse of a function. So some new vocab is inverse relation and inverse function. So Randall is writing a report on Santiago, Chile, and he wants to include a brief climate analysis. He found a table of temperatures recorded in degrees Celsius, and he knows that a formula for converting degrees Fahrenheit to degrees Celsius is C of x equals 5/9 times the quantity x minus 32. He will need to find what's called the inverse function to convert from degrees Celsius to degrees Fahrenheit. So in the table, he has the max and min temperatures in degrees Celsius. Now this formula tells you what the temperature is in Celsius if you already know what it is in Fahrenheit. Well, he wants to do the opposite. He wants to go from Celsius to Fahrenheit. So he'll have to figure out what the inverse is. So an inverse relation is a set of ordered pairs obtained by exchanging the x and y coordinates of each ordered pair in the relation. So if 5, 3 is an ordered pair of the relation, then flip-flop those. 3, 5 is an ordered pair of the inverse relation. So in words, if one relation contains the element or the coordinate a comma b, then the inverse relation will contain the element or the coordinate b comma a. So if you have a bunch of points like 3, -16, on the original, the inverse would be -16, -3. If you have -1, 4, then the inverse would be 4, -1. If you have 2, 14, the inverse would be 14, 2. And then if 5, 32, the inverse would be 32, 5. All you're doing is flip-flopping the coordinates. You're not making them, changing them to positives or negatives. You're not changing the sign or taking the reciprocal. All you're doing is, it's really, really simple, flip-flopping the coordinates to get the inverse. Okay, notice that the domain of a relation becomes the range of its inverse, and the range of a relation becomes the domain of its inverse. Okay, so remember the set of the x coordinates is known as the domain, and the set of the y coordinates is known as the range. All right, now when you flip-flop those, the domain of the original becomes the range of the inverse, because you took all the x values and made them the y values. Okay, so you took all the elements of the domain through, and now they're the range of the inverse. Similarly, for the range of the original, those all become the domain of the inverse. So all the y values of the original function or relation become the domain values of the inverse. Okay, it's just another way to look at it with domain and range. Okay, so let's find the inverse of each relation. So this relation is a set of 4 ordered pairs. And here's what we do. To find the inverse, all you do is exchange the coordinates of the ordered pairs. So I just listed all 4 ordered pairs here. All you do is flip-flop the x and y values to get the inverse. It's really that simple. So the inverse, if you list them in set notation, is right here, these 4 ordered pairs, and all we did was flip-flop them. Okay, now here we have a table. Well, to get the inverse, you could just rewrite all the values of the table as ordered pairs and then flip-flop them. So -4, -13 would become -13, -4. -1, -8.5, that x and y coordinate would become -8.5, -1, and so forth and so on for the last 2. So if I list it, the inverse in set notation, it's this one, this one, this one, and this one. All right. Okay, so here's one for you to try. Go ahead and find the inverse of this relation, then hit play of each one. Pause the video, then hit play when you're ready to check. Okay, so we're back. So 1A, the set would be 8, -6, 11, -15, 3, 9, and 6, 0. Okay, so that's 1A. 1B would be 5, negative 10, 11, negative 4, 12, negative 3, and 15, comma 0. Okay? It's really that straightforward. You just flip-flop the x and y coordinates and write your points. Okie dokie. All right, so the graphs of relations can be used to find the graphs of inverse relations. So if I want to graph the inverse of this relation right here, okay, so this is, it looks like a line, linear line. It has a y-intercept of 1, has a slope of up 1 over 1, so I know the equation of that line would be y equals 1x plus 1. Don't need to know that. I was just kind of reviewing that for your sake. So the graph of the relation passes through some points. We could pick off points of the graph. So it passes through negative 4, negative 3 right here. Negative 2, negative 1 right here. 0, 1 right here. 2, 3 right about there. And 3, 4 right about there. So all you have to do is just write down, since it's a line, all you have to really do is write down 3 or 4 points, flip-flop the coordinates of those points, plot them. If you did it right, they should go in a line, right? And then connect those points. So we actually did 5 here for this line, flip-flop them, and then when you graph them, they look like this. And you connect them with the line, and it's the green line. Now, it looks like the inverse, you just slid the line down or slid it over a little bit, okay? And we'll talk about what that means in a minute. So here you guys go. Go ahead and try to graph the inverse of each of these relations and then hit play when you're ready. Go ahead, pause the video. Okay, we're back. So this graph goes through the point negative 4, 2, negative 1, 1, 2, 0, and 1, 2, 3, 4, and 5, negative 1. So I just flip-flop the points. 2, negative 4, 1, negative 1, 0, 2, and negative 1, 5. So if I plot 2, negative 4, sorry, 1, negative 1, 0, 2, and negative 1, 5, looks like that. And you have your line there. Okay, so that's that one. Let me just block that off. So this one has the point negative 1, 2, 3, 4. So negative 4, 0, negative 1, 1, 2, 2. And actually that's enough. So flip-flop the points. Okay, so 0, negative 4 would be right here. 1, negative 1 would be right here. 2, 2 would be right here. If you connect them with a line, it goes right there. So you'll see that the inverse isn't necessarily just shifting the line up or down. It's really, well, we'll talk about it in a minute, but don't think it's just that simple, okay? You really do have to get a couple points on the original line, flip-flop the coordinates, graph those, and then connect them with a line to get the new inverse, okay? So the graphs from example 2 are graphed on the right with the line y equals x. Notice that the graph of an inverse is the graph, and this is what I was talking about, is the graph of the original relation reflected over the line y equals x. So if I just go back here and put these back on, okay, if I graph the line y equals x here, okay, this point right here is flipped over the line, comes down here. This point right here is flipped over y equals x, comes here. This point here is flipped over the line and comes here. and this point is flipped over the line y equals x and comes here. Notice same thing on this one. Notice this point flips over to this one flips over here. This one, since it's 2, 2, it has the same x and y coordinate. When you flip it, it lands on itself, okay? And then these points over here are flipped up to over here. Okay, so I wanted to point that out to you, clear that off. So for every point x, y on the graph of the original relation, the graph of the inverse will include the flip-flop of that point, y comma x. Okay, pretty cool stuff. So that's it for this first section, for the first video of this one. Next, we're going to talk about inverse functions. So this was inverse relations. Let's talk about inverse functions. We'll see.